Have you ever wondered why the falling apple began a revolution? Today, we'll uncover the secrets that have puzzled scientists for centuries. What if I told you that gravity is not what it seems? Let me explain. In the quiet orchard of history, a simple act of curiosity changed everything. Isaac Newton watched an apple fall and wondered why. That moment of awe pulled the world into a new age of reason. He saw that the same invisible pull that drew the apple to the ground also held the moon in its orbit. Gravity, he said, was a universal force stretching from the familiar Earth to the farthest star. For more than 2 centuries, his equations guided ships across oceans and planets across the sky. But gravity, the most obvious of nature's influences, was also the most mysterious. Every other force in nature could be shielded, reversed, or cancelled. Magnetic poles could flip. Electric charges could oppose. But gravity had no opposite. It was pure attraction, endless and patient. Newton could describe it, but he could not explain what it truly was. His laws spoke of how bodies move, but not of why they feel this pull through the emptiness of space. He imagined it as an invisible thread reaching through the void, a kind of action at a distance. To him, it was the mind of God at work in geometry. Then, centuries later, another mind took up the puzzle. Albert Einstein saw that gravity was not a force at all, but the shape of reality itself. Mass and energy, he said, tell space-time how to curve, and that curvature tells matter how to move. The falling apple is not being pulled downward. It is following the straightest possible path through a warped geometry. In this view, the planet Earth does not tug on the apple. It bends the stage beneath it. Einstein's vision turned gravity from an invisible rope into a kind of music. Space and time were not empty containers, but living fabric woven together into a single continuum. Light bends around stars not because it feels a force, but because it travels through a curved geometry created by those stars. Planets orbit because space-time itself flows in circles around mass. Yet even Einstein's brilliance left a question untouched. His equations told us how space-time behaves, but not what it is made of. The theory described the curvature of a fabric, but never its threads. What is this thing that can stretch, bend, and ripple like a living skin? How can emptiness itself have a texture? We can measure space-time's curvature. We can detect the waves it sends across the cosmos when black holes collide. We can even use its distortions to map invisible matter. But we cannot explain why space-time exists at all. In Einstein's equations, it is simply there, a fundamental stage on which all of reality unfolds. But perhaps it is not fundamental. Perhaps the geometry itself is built from something deeper, something woven into the quantum foundation of nature. The problem is stark. General relativity, Einstein's great theory, describes the cosmos on the largest scales. Quantum mechanics, its strange sibling, rules the smallest. Both work with uncanny precision in their domain, yet they refuse to fit together. Physicists have spent decades searching for a bridge between these worlds. Strings, loops, membranes, extra dimensions. Every idea points to a deeper structure, yet the true fabric remains elusive. And so, after all our equations, we find ourselves circling the same question that haunted Newton. What connects the apple to the Earth? What holds the universe together when everything else seems to fall apart? Some suspect that the answer lies not in the geometry of space, but in the relationships between the quantum states that fill it. Beneath the smooth stage of Spacetime, they imagine a web of invisible links, quantum correlations that tie particles together beyond distance. This phenomenon already has a name: quantum entanglement. 2 particles once connected can remain in a single shared state, even when separated by light years. Einstein, uneasy with this idea, called it spooky action at a distance. He believed nature must hide some unseen variables that restore local order. But the universe disagreed. Decades of experiments have shown that entanglement is real, that the world itself is built on correlations beyond any classical notion of separation. If gravity is the geometry of space-time and entanglement is the geometry of information, could the two be the same? Could the fabric of space-time emerge from the web of quantum connections that underlie? To understand the force that is not a force, we may need to accept that space and time themselves are not the beginning of the story. They might be the end, the shadow cast by something deeper, more abstract, and infinitely interconnected. Perhaps gravity, the most ancient mystery, is not a fundamental pull at all, but the gentle echo of quantum entanglement playing out on the cosmic scale. The more we learn about the cosmos, the more this idea feels inevitable. Every experiment in physics has revealed that what we once thought of as solid, separate, or absolute is in truth woven from relationships. Even the simplest atom is not a miniature solar system of hard spheres, but a dance of probabilities, a cloud of likelihood bound by invisible rules. Matter is no longer a collection of things. It is a pattern of information, a structure of relationships that persists through change. When Einstein spoke of spacetime, he imagined a smooth continuum, continuous and infinitely divisible. But quantum mechanics whispers a different story. Nothing in nature is truly continuous. Every vibration of energy, every field, every bit of light or matter comes in discrete packets. The universe, it seems, is not written in ink, but in pixels of existence. If space-time is real, it too must have a smallest unit, a grain, a quantum of geometry. Physicists call this quantum gravity's riddle. Imagine you stand at the edge of a grand tapestry, each thread representing a quantum state, woven into the fabric of space-time itself. The threads are intricate patterns of entanglement, connecting every atom to every other particle across the universe. This cosmic web is what gives rise to gravity as we know it today. The falling apple, the orbiting moon, and the slow dance of galaxies all may be expressions of one truth, that the universe prefers unity over separation. Wherever entanglement grows, space-time grows with it. But where it fades, space shrinks or tears apart like a thread unraveling from its tapestry. Gravity, once thought to be forces acting across vast distances, now begins to sound like a story of relationships and information. The geometry we see as gravity is simply the way this network seeks balance. Matter curves space-time because matter concentrates information. The more concentrated, the more the network strains, pulling nearby nodes inward. The cosmos could be thought of as a grand entangled system where every atom, every photon, every grain of dust participates in a shared quantum state too vast to imagine. This view transforms the question itself. Instead of asking how gravity acts across distance, we ask how distance arises at all. What we call space might not be the stage for matter and energy, but rather a product of their entanglement, a reflection of how information connects across the universe. When Einstein wrote that gravity is geometry, he described how the universe behaves when space-time emerges from patterns of entanglement. Now, as we follow this trail, the picture of gravity begins to dissolve into something subtler. We once imagined a universe of objects pulling on one another across a silent void. But the void seems alive, humming with correlations that defy distance. What we call emptiness may in truth be the densest structure of all, a boundless web of entanglement holding everything together. Einstein's equations describe this web as a curvature, but perhaps curvature is only the shadow we see when the invisible threads of quantum information tighten or slacken. Just as the ripples on a pond reveal the movement of water below, space-time geometry could reveal the shifting relationships within a deeper network of quantum links. This idea solves old puzzles that have haunted physics for a century. Why does space-time curve smoothly, yet quantum fields fluctuate in discrete quant? Why do black holes store information in proportion to their surface area rather than their volume? Each of these mysteries makes sense if gravity is not fundamental but emergent, the large-scale pattern created by countless quantum entanglements. The story of gravity is not one of attraction but of connection. To understand what may lie beneath gravity, we must enter the strangest domain of all the quantum world. In this realm, certainty fades. Objects dissolve into waves of probability. Reality no longer exists as a fixed thing, but as a cloud of possibilities waiting for observation to make it real. Quantum entanglement is perhaps the most mysterious feature of nature ever discovered, a mathematical oddity that describes how particles behave when they interact. When two particles meet, exchange energy, and then separate, their quantum states become shared and inseparable, interdependent. Measure one and the other responds instantly, as though some invisible thread connects them through the void. Einstein could not accept this, arguing for hidden variables to explain the phenomenon. But experiments have shown that correlations between entangled particles obey strict limits, violating any local hidden variables. The implications are profound. Reality is not built from things, but from relationships. Information is more basic than matter or energy. The universe at its core is an information processing system, and entanglement is its language. Every time two particles interact, a record of that interaction persists in the form of shared quantum information, a thread in the cosmic tapestry. The web of entanglement extends across the entire cosmos, connecting every atom to every other. Entanglement does not send messages or transmit energy faster than light. It defines the structure of reality itself. When we say two particles are entangled, we are saying they share a single unified description. No distance can undo that unity. Measure one and you merely reveal what was already true of the combined system. This is not mystical but mathematical. The universe does not behave like a collection of independent parts. Its components are intertwined in patterns of shared information. Perhaps this is why attempts to divide the universe into smaller pieces never quite reach an end. Every boundary we draw is artificial. The deeper we look, the more we find that everything is entangled with everything else. And if space-time itself arises from patterns of entanglement, then these invisible threads may be the true architecture of reality. The same correlations that tie two electrons across a laboratory may bind entire galaxies together across the universe. The next question is how far this web extends and whether the fabric of the universe itself is just one vast quantum network, an ocean of entanglement from which space and time emerge as surface waves. If we could see the universe not with our eyes, but with instruments tuned to quantum connection, the scene would astonish us. Between every particle, every photon, every atom, there would shimmer faint threads of entanglement, crossing and weaving into an unimaginable web. The stars themselves would not stand alone. Their light and gravity would emerge from a deeper harmony in this invisible network. You know, we often think of the universe as a vast collection of separate parts. But what if that's not entirely true? The universe is actually an intricate web of relationships between all its components, and this idea is at the heart of something called entanglement. Entanglement is a phenomenon where two or more particles become connected in such a way that their properties are correlated, regardless of the distance between them. This means that if you measure the state of one particle, you instantly affect the state of the other, even if they're separated by billions of kilometers. This concept challenges our classical understanding of space and time. We've always thought of objects as existing independently in space, but entanglement shows us that this is not necessarily the case. The universe is more like a vast network of interconnected information, where every particle plays a role in the collective behavior of the system. When we look at the universe through the lens of entanglement, everything starts to seem more connected than it initially appears. We see that even distant stars are linked by invisible threads of quantum connection, and that the geometry of space-time itself arises from these patterns of entanglement. This idea may sound like science fiction, but it's actually supported by experiments and observations that confirm its validity. The Delft experiment, for example, demonstrated the existence of entangled particles in a laboratory setting, and similar effects have been observed in other systems as well. So what does this mean for our understanding of reality? It suggests that information is more fundamental than matter or energy. The universe at its core is an information processing system, and entanglement is the language it speaks. Every time two particles interact, a record of that interaction persists in the form of shared quantum information, which extends across the entire cosmos. This realization changes everything. It means that we need to rethink our notions of distance, space, and time themselves. We used to think that these concepts were absolute, but entanglement shows us that they're actually relative, dependent on how connected the universe is at different scales. The implications are profound. If the universe is an entangled network, then what we call distance may simply measure how directly or indirectly two regions are connected in that network. This idea has been dubbed quantum non-locality, and it challenges our classical notions of causality and space-time. So, what does this mean for us as observers? When we look at the universe, we're not just seeing objects, we're witnessing the faint echoes of a universal entanglement that has never been broken. Every atom in our bodies was forged from matter that once shared quantum ties with the rest of the cosmos. And those ties still exist, humming quietly in the background of existence. The question now is whether we can measure this web of entanglement that underlies space-time. Can we detect its patterns, quantify its density, or even manipulate it? To answer these questions, we need to turn to some of the most exciting ideas in modern physics, such as the holographic universe, where information on a two-dimensional surface can describe the entirety of three-dimensional reality. The holographic universe is like a cosmic tapestry, woven from threads of entanglement that stretch across space and time. It's a vast network of interconnected information, where every particle plays a role in the collective behavior of the system. When we look at this idea, we're forced to confront what we mean by reality itself. We used to think of the universe as a collection of separate things, but entanglement shows us that everything is actually connected. The universe is not just a bunch of objects, it's a single conversation, a continuous exchange of information that unfolds across space and time. This realization can be both exhilarating and unsettling. It challenges our classical notions of space, time, and causality, and forces us to rethink our understanding of the world around us. But it also offers us a glimpse into a deeper reality, one that's full of wonder, mystery, and connection. In this sense, entanglement is not just a phenomenon, it's a way of understanding the universe itself. It's a reminder that we're all part of something greater than ourselves. Something that connects us to every other particle in the cosmos. Imagine that the solidity of the world is an illusion, born from the overwhelming scale of entanglement. We see stability not because the universe is static, but because it is perfectly coherent. Entanglement is what allows the universe to remember its own shape. It is the continuity that turns chaos into cosmos. If that continuity were ever broken, if the links connecting all systems were somehow severed, space itself would lose its meaning. The distances between things would dissolve and geometry would collapse into a fog of uncorrelated quantum noise. In that instant, space-time would vanish because there would be no relations left to define it. This possibility is not just poetic speculation. Some theoretical physicists suggest that the very stability of space-time depends on the persistence of entanglement. The structure of the universe may be a kind of quantum fabric, constantly rewoven by the exchange of information between particles and fields. Every interaction adds new threads, strengthening the coherence that keeps reality intact. And this view offers a new perspective on gravity. When we think of gravity as attraction, we imagine masses pulling at each other. But if space-time itself arises from entanglement, then gravity may simply be the pattern that emerges when that network bends under the weight of information. The more entangled a region is, the more tightly its geometry connects. Where entanglement weakens, geometry stretches. In this way, gravity could be nothing more than the manifestation of quantum connectedness on a cosmic scale. The same principle that governs two entangled photons in a laboratory could also govern the curvature of space-time near a black hole. The quantum and the cosmic may be two expressions of the same phenomenon, one glimpsed in microscopic systems, the other written across the sky. This understanding reshapes how we think about energy, mass, and even identity. If everything is entangled, then no system is ever truly isolated. Every particle carries the memory of every interaction it has ever had. And through those interactions, it remains linked to the rest of the universe. When we measure a particle, we do not simply observe it. We join it. We become part of its story, entangled with its outcomes. Observation is not a window into reality. It is a participation in it. Perhaps this is why the act of measurement appears to collapse quantum uncertainty into a single outcome. When we measure, we are not forcing the universe to choose. We are aligning ourselves with one branch of its vast, entangled network. The observer and the observed become one node in a greater pattern. The holographic view also explains a puzzle that haunted physics for decades. The information paradox. When matter falls into a black hole, what happens to the information it carries? According to classical general relativity, the information is lost forever, erased from the universe. But quantum mechanics insists that information cannot be destroyed. The holographic principle resolves this conflict. The information is not lost. It is written on the event horizon, preserved in the ripples of the cosmic code. From this perspective, black holes are not prisons but libraries. Each surface a vast archive of quantum states. Their gravity is simply the curvature of information. Their heat the vibration of the code itself. The entire universe then could be one grand holographic field, every event a line in the script of existence written on its boundary. If this is true, then quantum entanglement is the author's pen. It is the process by which information on the boundary translates into geometry within the bulk. The patterns of entanglement define which regions of the holographic screen are connected, which are distant, and how space itself bends between them. The more entangled two regions are, the closer they appear in space-time. When entanglement fades, the connection stretches and distance grows. In this way, the holographic universe and entanglement are not separate ideas, but two faces of the same truth. The holographic principle explains where the information resides. Entanglement explains how it binds the universe together, and through that union, a new picture of gravity begins to form, not as a fundamental force, but as the natural outcome of how information organizes itself across the cosmic boundary. If the holographic principle is true, then the universe is not a physical structure expanding through a void, but a vast computation, an unfolding of information across an invisible surface. Every point of space, every flicker of time is the result of how data is stored, transformed, and entangled within that cosmic code. The stars we see are projections, luminous patterns generated by the underlying logic of quantum information. To understand this, imagine a hologram etched into glass. The surface itself contains no depth. It holds only a maze of interference patterns, lines of light and dark encoding the relationships between waves. Yet when illuminated, the hologram reveals a full three-dimensional image that seems to hover in space. Depth appears from patterns, not from matter. The holographic universe may work the same way. Imagine a universe where everything is connected, where every particle, every wave, and every bit of data contributes to the total pattern. This is the world of the holographic principle, where information is not just a description of reality, but the reality itself. It's written on the event horizon, preserved in the ripples of the cosmic code. From this perspective, black holes are not prisons but libraries. Each surface a vast archive of quantum states. Their gravity is simply the curvature of information. Their heat the vibration of the code itself. The entire universe then could be one grand holographic field, every event a line in the script of existence written on its boundary. If this is true, then quantum entanglement is the author's pen. It is the process by which information on the boundary translates into geometry within the bulk. The patterns of entanglement define which regions of the holographic screen are connected, which are distant, and how space itself bends between them. The more entangled two regions are, the closer they appear in space. When entanglement fades, the connection stretches and distance grows. In this way, the holographic universe and entanglement are not separate ideas, but two faces of the same truth. The holographic principle explains where the information resides. Entanglement explains how it binds the universe together. And through that union, a new picture of gravity begins to form, not as a fundamental force, but as the natural outcome of how information organizes itself across the cosmic boundary. If the holographic principle is true, then the universe is not a physical structure expanding through a void, but a vast computation, an unfolding of information across an invisible surface. Every point of space, every flicker of time is the result of how data is stored, transformed, and entangled within that cosmic code. The stars we see are projections, luminous patterns generated by the underlying logic of quantum information. To understand this, imagine a hologram etched into glass. The surface itself contains no depth. It holds only a maze of interference patterns, lines of light and dark encoding the relationships between waves. Yet when illuminated, the hologram reveals a full three-dimensional image that seems to hover in space. Depth appears from patterns, not from matter. The holographic universe may work the same way. The three-dimensional world we experience with its distances, volumes, and motions could be a projection from a two-dimensional boundary. The structure of that boundary is written in quantum information encoded at scales far smaller than any particle we can detect. In this view, gravity becomes the way the hologram responds to changes in its information. When energy or matter moves within the projection, the boundary must reconfigure its data to remain consistent. That reconfiguration appears to us as the bending of spacetime. The very effect we call gravity is not a pull from one object to another. but a change in the relationships between the bits of information defining the universe. This concept also offers insight into why black holes behave so paradoxically. Their surfaces act as the ultimate boundaries, storing information about everything that falls within. The interior we imagine is not a hidden realm, but a projection from the event horizon's data. What we perceive as the crushing center of a black hole is simply the limit of that projection, where the code structure reaches a point of infinite compression. Even more extraordinary, the holographic principle may explain why the universe itself exists with just the right conditions for life and order. If space-time emerges from quantum information, then its laws are not arbitrary. They are dictated by the mathematical consistency of the code. The same rules that create geometry also create stability, allowing matter to form, stars to burn, and consciousness to arise. The harmony we observe in nature may be the reflection of a deeper harmony within the information that composes it. Physicists have tested these ideas using models inspired by Muldesener's ADS CFT correspondence. In these models, a quantum field theory without gravity on the boundary precisely mirrors a gravitational theory within a curved space. This duality means that every equation describing quantum particles on the surface has a counterpart describing space-time geometry inside. The two are not separate worlds, but different perspectives on the same reality. When the field theory's particles become more entangled, the geometry inside becomes more connected. When entanglement is removed, space inside begins to tear apart. In this way, the smoothness of spacetime depends entirely on the coherence of quantum information at its boundary. This is more than a mathematical trick. It is a potential answer to one of the deepest questions in physics. Why does spacetime hold together at all? Imagine now that the entire cosmos functions as a single vast holographic system. The boundary, perhaps at the farthest edge of the observable universe, encodes all the information within. Each bit of that boundary interacts with others through quantum entanglement. And those interactions generate the appearance of space, time, and gravity inside. Every planet, every galaxy, every heartbeat is a flicker in this projection, an event in the story being told by the boundary's code. If this is so, then information is not merely a description of the universe. It is the universe. Energy, matter, and spacetime are secondary manifestations of information relationships. Reality is what information does when it is self-entangled. This vision aligns with something deeper in human intuition. We have always sensed that knowledge and being are intertwined. The more we observe, the more we realize that observation itself shapes the world. In a holographic universe, this is literally true. Our measurements are not passive. Each act of perception rewrites a tiny part of the cosmic code, linking us into the very fabric of existence. The holographic principle also restores a sense of wholeness that physics once lost. When we dissect reality into smaller pieces, we find not independence but interdependence. The universe resists isolation. Every particle, every wave, every bit of data contributes to the total pattern. Remove one and the entire projection changes. Gravity in this framework becomes a story of how information balances itself. It is the universe's way of maintaining coherence. Where the information-ational density increases, geometry bends inward. Where it decreases, space stretches outward. Motion, attraction, and curvature are all expressions of the same underlying drive toward information-ational equilibrium. Yet there remains a mystery. If everything we see is a projection from a boundary, what lies beyond that boundary? Is it physical, like a surface we might someday reach, or purely mathematical, an abstract domain where the laws of nature are written? Some physicists believe the boundary exists only in our equations, a convenient way to represent how information flows. Others suspect it may be a real horizon, a cosmic shell encasing the universe itself. Whatever its nature, the holographic principle suggests that the structure of reality is far more profound than matter and energy alone. It tells us that what we call space may be nothing but the shadow of quantum entanglement, a reflection cast by information dancing at the edge of existence. And in that realization, we begin to see that gravity, entanglement, and information are not separate phenomena, but different expressions of the same truth. That connection is the foundation of everything. If we could step outside the universe and gaze upon its true form, we might not see a vast void scattered with galaxies, we might see a luminous sphere of information, every point of its surface encoding the totality of existence within. The galaxies, the stars, the thoughts and dreams of sentient beings would appear as patterns in the light upon that cosmic shell. Depth would be an illusion born of perspective, a projection cast inward from a two-dimensional sea of quantum data. This image may sound poetic, but it arises from mathematics as precise as any in physics. When Juan Maldacena revealed that a universe with gravity can be equivalent to a gravity-free quantum field theory defined on its boundary, he uncovered something extraordinary. Spacetime itself may be a hologram, an emergent construct woven from the logic of information. The implications ripple outward like waves from a stone dropped into still water. If every point in space is encoded on a surface, then locality, the idea that nearby things interact more strongly than distant ones, is not fundamental. It is a pattern arising from how information is organized. Regions that are closely connected in the boundary's quantum code appear close together in the holographic projection. Regions that are weakly connected seem far apart. Distance, then, is not a measure of separation, but of information-national relationship. This turns our intuition inside out. We think of information as describing the world. But here information is the world. The structure of the code defines the geometry of reality. The curvature of space-time is the shape of information itself. Gravity, that ancient mystery, becomes a story about how information bends under its own weight. Imagine a universe where information is the foundation of reality, where every law of nature, every field and particle, every flow of energy arises from the logic of information conservation. This idea may seem poetic, but it's rooted in mathematics as precise as any in physics. The concept of quantum data and its relationship to space-time has been a topic of debate for centuries. Consider the surface of a black hole, which is not a hole at all, but a holographic record, a perfect storage device where the interior is nothing more than a projection. This idea challenges our understanding of reality's balance. The surface area of any region of space limits how much information it can contain. This boundary law governs everything from black holes to the quantum foam at the smallest scales. The holographic model also gives us a clue about how gravity emerges. According to Juan Maldacena, the curvature of space-time inside the holographic world is determined by the amount of entanglement on its boundary. When entanglement increases, space-time becomes more connected. When it decreases, space-time tears. Gravity, therefore, is the macroscopic expression of quantum entanglement, preserving coherence across the holographic code. It's not a force that acts upon things, but a geometric translation of information-seeking balance. In this picture, even the expansion of the universe gains a new meaning. As cosmic time unfolds, the informational content of the boundary grows. More data becomes encoded, and the projection within expands accordingly. The accelerating spread of galaxies across the void may reflect not a physical explosion, but the unfolding of new information on the cosmic horizon. Space grows because the universe continues to compute itself. This perspective reframes our place within the cosmos. We are not inhabitants of a three-dimensional realm floating through emptiness. We are patterns within a grand holographic computation, complex arrangements of information sustained by the entanglement that underlies space and time. The most astonishing aspect is that this view unites all the great mysteries of physics, black holes, quantum mechanics, thermodynamics, and gravity under one principle. Information is the foundation of reality. The laws of nature, fields and particles, energy flows arise from the logic of information conservation. Even entropy, the measure of disorder, becomes a measure of how information is distributed. Einstein's geometric universe and the quantum world's probabilistic nature no longer stand apart. They are two sides of the same information-national coin. Geometry emerges where entanglement orders information. Probability arises where information is incomplete. Together they form the dual image of a single underlying truth. Reality is a self-organizing network of entangled data. If this is correct, then the gravitational pull we feel on Earth is not the tug of an invisible force, but the manifestation of our planet's information-national imprint upon spacetime's holographic code. The curvature that keeps the Moon in orbit and bends light around the Sun is the shape of information coherence. When we drop a stone, we are not obeying a force of attraction, but following the path inscribed by the geometry of information. Gravity becomes not an external influence, but an internal necessity. It's the universe's way of remaining consistent with itself, ensuring that information flows without contradiction. Every orbit, every fall, every ripple in Spacetime is the universe maintaining the integrity of its own code. As we continue to explore the mysteries of physics, a new understanding begins to take shape. The holographic universe shows that spacetime is not the foundation, but the consequence of quantum entanglement. Gravity is the visible echo of invisible correlations written on the boundary of existence. In the chapters ahead, this idea will be sharpened into something even more startling. In 2010, a physicist named Mark van Ramden proposed that increasing or decreasing entanglement literally connects or disconnects regions of spacetime. His revelation would transform the holographic vision into a living geometry, one in which the very fabric of the cosmos is woven from entanglement. And through his insight, gravity's true nature would begin to reveal itself not as a force, not even as curvature, but as the ultimate expression of connection. Imagine if everything in our lives was connected in ways we couldn't see or touch. A thread of entanglement that binds us to every star, every photon, and every atom in existence. This idea may sound like science fiction, but it's actually a revelation from quantum theory. When we drop a stone, we're not obeying an external force called gravity, but following the path inscribed by the geometry of information. It's as if the universe is one vast network of wormholes and entanglement connections that give rise to gravity. Think of these connections as invisible filaments that form the structure of space. The concept that every entangled pair in the universe contributes to its geometry may sound staggering, but it's actually a profound idea. The universe isn't just particles moving through an empty void, it's a vast tapestry of entanglement, and gravity is its texture. Imagine the cosmos not as a collection of isolated objects, but as a glowing web of relationships. Each filament in this web represents entanglement, an invisible bridge binding distant regions of space. Where these filaments tighten, geometry curves, and where they loosen, distance stretches. And when they snap entirely, space itself fractures. This curvature manifests as gravity in the equations of relativity, but as entanglement, entropy in quantum theory. The smoothness of space is not a given, it's maintained by the delicate balance of quantum connections that weave through every corner of existence. Van Ramsden's insight forces us to rethink what it means for the universe to be connected. It's not just particles moving through space, but the arena itself being sustained by their relationships. The structure of the cosmos is built upon intimacy, the quiet fact that everything is correlated with everything else. If one could somehow turn down the volume of entanglement, the universe would begin to fade, and its geometry would lose coherence. This thought experiment isn't just a metaphor, it's predicted by the mathematics of holography. When physicists simulate a decrease in entanglement within a boundary system, the corresponding bulk geometry begins to fragment. What was once a single continuous space splits into disconnected pieces. The destruction of entanglement is the destruction of space. This realization is profound. Space and gravity are not fundamental but emergent phenomena arising from quantum connections. The universe isn't made up of objects moving through an empty void, it's made up of relationships that produce space and energy as side effects. Geometry, gravity, and even time itself are emergent properties, the large-scale consequences of countless microscopic acts of entanglement. This idea reframes one of physics' oldest questions: why does gravity feel so weak compared to other forces? If gravity is not fundamental but emergent, its weakness is no longer mysterious. It's simply a faint echo of a vast formation process, spread thin across the universe. The web of entanglement is strong in its unity, but gentle in its pull. Consider an analogy: temperature is not a property of individual molecules, but an emergent phenomenon that arises when we describe their collective behavior. In the same way, gravity emerges from the collective structure of entanglement. Just as heat flows to equalize energy, gravity strives for balance by equalizing information. Einstein's field equations become the thermodynamics of space, a statistical expression of quantum entanglement seeking harmony. Each curve of geometry represents a difference in informational density. Matter tells space-time how to curve, because it concentrates information, and space-time responds to preserve equilibrium. Gravity is not what pulls us toward the Earth, but what keeps us connected to the universe itself. The more we follow this trail, the clearer the picture becomes space, that gentle continuum. May not be continuous at all, it's a tapestry of quantum threads, each thread a link of entanglement holding the universe together. The distances we measure are not fundamental lengths, but reflections of how tightly or loosely those threads are woven. When Van Ramsden first proposed that entanglement constructs geometry, many thought it was an abstract mathematical curiosity. But over time, evidence from diverse fields began to converge toward the same conclusion: the pattern is connection. In this view, the cosmos isn't made of space and then filled with energy, it's made up of relationships that produce space and energy as side effects. Geometry, gravity, and even time itself are emergent phenomena arising from quantum connections. This idea reframes one of physics' oldest questions: why does gravity feel so weak compared to other forces? If gravity is not fundamental but emergent, its weakness is no longer mysterious. It's simply a faint echo of a vast formation process spread thin across the universe. The web of entanglement is strong in its unity, but gentle in its pull. Consider an analogy: temperature is not a property of individual molecules, but an emergent phenomenon that arises when we describe their collective behavior. In the same way, gravity emerges from the collective structure of entanglement. Just as heat flows to equalize energy, gravity strives for balance by equalizing information. Einstein's field equations become the thermodynamics of space, a statistical expression of quantum entanglement seeking harmony. Each curve of geometry represents a difference in informational density. Matter tells space-time how to curve because it concentrates information, and space-time responds to preserve equilibrium. Gravity is not what pulls us toward the Earth, but what keeps us connected to the universe itself. The more we follow this trail, the clearer the picture becomes space, that gentle continuum. May not be continuous at all, it's a tapestry of quantum threads, each thread a link of entanglement holding the universe together. As we step back from this picture, a quiet elegance emerges. The universe doesn't need an external force to hold it together. It's held by its own web of connections, a vast network of entanglement that binds everything in existence. This idea blurs the boundary between existence and relation, between being and becoming. To be real in this universe is to be connected. Isolation is an illusion. Even emptiness is full, not a matter but of entanglement. We are part of this architecture, our atoms, our memories, our thoughts, all encoded in the same web that holds galaxies in orbit. Consciousness in this light is not an observer standing apart from the universe. It's an emergent pattern within the same informational flow. Van Ramsden's insight has deep implications for philosophy and how we see ourselves within the cosmos, a realization both humbling and beautiful that connects us all to something greater than ourselves. You've reached the point where Einstein's field equations begin to reveal their true nature, a reflection of the universe's own thermodynamics, its quest for balance and harmony through information flow. The more we follow this thread, the clearer it becomes that space itself is not just a passive backdrop, but an active participant in the grand dance of entanglement. Imagine the entire cosmos as a vast tapestry woven from threads of quantum connection. Each node represents a concentration of information, and the geometry of space-time responds to preserve equilibrium. Gravity is no longer seen as a force pulling objects together, but rather as the natural consequence of information seeking harmony within this intricate web. The concept of a singularity begins to shift as well. No longer an abyss where physics breaks down, it becomes a point where the quantum network collapses, where connections are torn apart and geometry fails. Black holes then become regions of extreme entanglement imbalance. Their gravitational pull a desperate attempt by the network to restore coherence. As matter falls into the void, its information is encoded on the event horizon, only to be released again through subtle quantum correlations as the black hole evaporates. The universe keeps its own accounting with perfect precision, maintaining balance and harmony at every scale. From this new perspective, reality takes shape, a universe of pure relation, where gravity whispers through the geometry of space-time. Space is born from entanglement, its structure resembling an immense web of quantum connections. Each node carries information, each link representing entanglement between states. The cosmos begins to resemble a vast living lattice of light, with every star pulsing as a node in the network and photons tracing threads of connection across vast distances. Even the vacuum shimmers with quantum links, an ocean of invisible filaments weaving reality together. As we step back from this picture, a quiet elegance emerges, the universe holding itself together through harmony and balance. Entanglement is the thread that weaves it all together, geometry the weave, and gravity the pattern that results when the thread tightens. The next question becomes inevitable: how does this quantum network give rise to the smooth classical spacetime we experience every day? The answer lies in models treating spacetime as a computation, a vast tensor network whose geometry is defined by information flow. In these models, gravity emerges naturally from the quantum web, its strength dependent on entanglement density. As we delve deeper into this vision, it's clear that the universe is not made of matter or fields, but of pure relation, a vast quantum circuit where every node exchanges information through entanglement channels. The geometry drawn by this dance defines the motion of energy and matter. Imagine tearing a hole in the fabric of spacetime, removing connections between nodes. The result is not just a gap in geometry, but a loss of information, revealing that what we perceive as motion through space is at a deeper level the reconfiguration of information within the network. The orbit of a planet around its star becomes an expression of information seeking equilibrium within this quantum web. Gravity waves may be the vibrations of this informational web, tremors in the network's entanglement structure propagating across the universe. Physicists are beginning to simulate these effects using mathematical structures called tensor networks, webs of quantum nodes linked by entanglement. When visualized, their patterns mirror the geometry of spacetime predicted by general relativity, demonstrating that gravity emerges naturally from the quantum web. The entire cosmos becomes a quantum computation running on the hardware of entanglement, every atom and field contributing to the universal calculation. The result is spacetime itself, a self-sustaining illusion of continuity generated from the logic of information. This realization brings us closer to understanding how this quantum network gives rise to the classical world we experience. How does the continuous geometry of spacetime emerge so perfectly from the discrete probabilistic dance of entanglement beneath? The next part will explore this bridge, delving into the heart of Einstein's equations and revealing a stunning truth that gravity may be nothing more than the whisper of connection, the echo of entanglement speaking through the geometry of spacetime. Imagine you're standing at the edge of a vast, shimmering web. It's the cosmos, alive with information and energy. The laws of physics we observe are not set in stone from some distant authority. They emerge from the intricate dance of entanglement within this quantum network. Every measurement we make is like taking a snapshot of the universe at that moment. We're not seeing ultimate reality, we're reading the current configuration of the network. The constants of nature, those seemingly fundamental building blocks of our understanding, are balance points within the cosmic web. They allow it to maintain coherence across unimaginable scales. In this view, the entire cosmos is a quantum computation running on the hardware of entanglement. Every atom, every field, and every fluctuation contributes to the universal calculation. The result of that computation is space-time itself, a self-sustaining illusion of continuity generated from the logic of information. The universe is not a static structure, but a dynamic conversation among its parts. Each event, every collision, and every emission of light sends messages through the web. These vibrations are what we experience as gravity, the curvature of space-time, and the bending of light around massive objects. But here's the fascinating part: this quantum network gives rise to the classical world we experience. It does so by processing its own data, step by step, moment by moment. The universe computes its own existence through an intricate web of relationships. In essence, gravity is not a fundamental force, but the statistical expression of the universe seeking information-national balance. When energy moves, entanglement changes. When entanglement changes, space-time curves. This realization brings us closer to understanding how the cosmos behaves like a computational system, self-updating and self-correcting. Every event in the universe is a calculation, and every movement is a computation. The universe computes its own existence through an intricate dance of information. In this view, classical laws of physics are not commands written by an external hand, but emergent programs running within the network. The beauty of Einstein's equations lies not just in their simplicity, but in the fact that they arise inevitably from the statistics of entanglement. Gravity is the cosmos speaking the language of information, its geometry the syntax, its curvature the grammar, and its waves and orbits the rhythm of meaning passing through the universal code. As we delve deeper into this perspective, we find that space itself emerges from the quantum web. The universe we inhabit is built not from empty coordinates, but from dynamic relationships between quantum nodes. Space is what connection looks like when viewed from within. Geometry what entanglement feels like to the entities entangled. In this sense, classical space-time, our familiar arena of stars, planets, and light is an illusion created by being too far away to see the intricate web of information. The transition from quantum to classical is not a sharp boundary, but a gradual smoothing out of the network's discrete complexity. When we measure, we're not collapsing reality, we're recalibrating it. Every measurement is an internal update within the universe, redistributing entanglement to maintain coherence. We as conscious beings are patterns within this web, complex arrangements of entanglement capable of reflecting upon themselves. In this context, even time itself arises from the process of entanglement, spreading and relationships growing. The arrow of time is not a fundamental property, but an emergent consequence of the universe's computational nature. The universe unfolds its own formational structure, extending the lattice of reality with each new connection. This perspective reshapes our understanding of the cosmos, no longer as a static object born in a singular explosion, but as a living computation that continues to evolve and create new space, time, and patterns of connection. As we continue to explore the mysteries of the universe, we find ourselves at a crossroads, where the boundaries between observer and observed begin to blur. The classical world of stars, planets, and galaxies is being reshaped by a new perspective, one that sees the cosmos as a vast web of entanglement. This is not just a theory, it's an experience, a way of understanding the universe that dissolves our traditional notions of space and time. Imagine zooming out from the microscopic tangle of information, where Einstein's geometry takes on a new shape. The act of observation no longer collapses the wave function, but rather updates the network, redistributing entanglement to maintain coherence. Reality doesn't collapse, it recalibrates. At this level, we are not passive observers peering in from outside, we are patterns within the network, complex arrangements of entanglement capable of reflecting upon ourselves. When we measure, we are momentarily looking back at the universe's own structure. The flow of information that defines the cosmos passes through us and continues outward, reshaping geometry as it goes. Even the direction of time may arise from this process, an arrow that points toward the accumulation of relationships and entanglement. Expansion is not just galaxies racing apart, it's the growth of connectivity, the unfolding of the universe's own informational structure. The cosmos doesn't stretch into emptiness, it extends its own formational structure, creating new space, new time, and new patterns of connection. The Big Bang becomes not a singular explosion, but the initial condition of entanglement, the first spark that set the network's self-weaving in motion. As we move forward, this understanding prepares us for the next step in the story. We begin to see the universe as a living computation, evolving and creating new space, time, and patterns of connection. The realization that geometry is emergent from information redefines what it means for the universe to be finite or infinite. If space arises from entanglement, then its boundaries are not physical walls but informational limits. As we delve deeper into this world, the old question, what is gravity, begins to fade. Gravity is no longer a mystery to be solved, it's a story to be understood, the narrative of information striving for coherence, the way the universe remembers its own shape, the whisper of memory that attracts masses together. Gravity is not a force, but an emergent phenomenon born from entanglement. In this framework, the physical and informational are inseparable. Matter and energy are the visible expression of the network's data. Gravity and geometry are the syntax of its relationships. Space and time are the dimensions of its meaning. The laws of physics are the grammar that allows it to speak consistently. And what it speaks is existence itself, a sentence still unfolding, written in entanglement, read in curvature, echoed in gravity. The connection between heat, information, and geometry reaches deep into the heart of nature. When matter falls toward a massive object, it increases the density of information in that region. The surrounding spacetime compensates by curving more tightly, redistributing entanglement to restore balance. The result is attraction not because of a force acting at a distance, but because the underlying network of information must remain consistent. The same principle governs black holes. Their surface area measures their entropy. Their temperature arises from quantum fluctuations at the horizon and their radiation. The faint whisper discovered by Stephen Hawking is the gradual equalization of information between inside and out. The black hole becomes a thermodynamic engine where gravity, entropy, and information are three aspects of a single process. From this perspective, space-time itself is alive with heat, every region possessing a temperature arising from the entanglement between quantum fields. If one were to accelerate through empty space, one would feel a warmth proportional to that acceleration, a phenomenon known as the Unruh effect. What seems to be cold vacuum is in truth filled with the thermodynamic vibration of information. This revelation dissolves the boundary between energy and geometry, the curvature of space-time no longer an abstract property of mass and energy, but the visible shadow of invisible information-national exchanges. When the density of information changes, space-time curves to accommodate it. The universe is not a rigid stage, it's a flexible medium that continuously readjusts itself as information flows through it. To see this in motion, imagine the moment a massive star collapses. As its core compresses, the entanglement of its quantum fields intensifies. Information becomes so densely packed that the network can no longer distribute it smoothly, and the geometry buckles, forming a black hole. The event horizon marks the threshold where the flow of information becomes so curved that even light cannot escape. Yet the entropy encoded on that surface preserves every detail of the star's existence, storing it as patterns of entanglement. The star's death becomes an act of transformation, its matter rewritten into the language of information. And in this way, we begin to see gravity not as a fundamental force, but as the universe's own self-regulation, the statistical drift of information toward balance. This understanding sheds light on why gravity cannot be easily quantized like the other forces. Gravity is an emergence, not a separate interaction, but a pattern that arises from countless entanglements speaking in unison. And yet this collective whisper governs the grandest phenomena in the universe, shaping the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. The laws of thermodynamics and gravity are two expressions of one principle: information cannot be destroyed, only transformed. When energy flows, information follows a truth that dissolves the boundaries between space and time, matter and energy, and observer and observed. You see, as we dive deeper into the mysteries of the universe, we begin to uncover a profound truth about its nature. It's not just a vast expanse of stars and planets, but a living, breathing entity that pulsates with energy and information. The geometry of space-time is like a delicate web, intricately woven from threads of entanglement, where every event is connected and interdependent. As Einstein once said, the most incomprehensible thing about the universe is that it's comprehensible. And I believe he was hinting at something even more profound, that the universe itself has an inherent capacity for self-awareness, a built-in intelligence that allows it to evolve and adapt over time. This is not just a philosophical notion, it's a fundamental principle that underlies all of existence. Consider the concept of gravity. We've long thought of it as a force that warps space-time, bending light around massive objects. But what if I told you that gravity is actually an emergent phenomenon, arising from the collective behavior of information itself? It's not just about the curvature of space-time, it's about the flow of entanglement, the dance of particles and waves as they interact with one another. This idea may seem abstract, but trust me, it has profound implications. If gravity is indeed an emergent phenomenon, then it means that the universe itself is a self-regulating system, adjusting its geometry to maintain balance and equilibrium at all scales. And what's even more remarkable is that this balance is not just about energy or mass, it's about information. Think of it like this: when you drop an object, what do you see? You see the force of gravity pulling it towards the ground. But what if I told you that's not just a force acting on the object, it's actually a manifestation of the universe's desire to balance its own information? The reorganization of entropy around a change in energy is what drives the object downwards, as the universe seeks to maximize its own coherence. This perspective changes everything. It means that gravity is not just a local phenomenon, it's a universal principle that underlies all of existence. And if we take this idea further, we begin to see the universe itself as a vast web of interconnectedness, where every event and every particle is linked in a delicate dance of entanglement. As we gaze out into the cosmos, we're not just seeing stars and planets, we're witnessing the unfolding of a grand tapestry, woven from threads of information that stretch across space and time. And at the heart of this tapestry lies a profound symmetry information seeks to spread, entanglement seeks to balance, and geometry arises to ensure that both remain consistent. This is not just a mathematical formula, it's a fundamental principle that underlies all of existence. It's the reason why gravity affects everything that carries energy or information, because it's not about forces acting on objects, but about the flow of entanglement itself. As we peer deeper into this tapestry, we begin to see the universe as a single, unified entity, where every event and every particle is linked in an intricate web of connection. And at its core lies a profound truth that the universe is not held together by force or power, but by understanding and balance. This realization has far-reaching implications for our understanding of reality itself. It means that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we drop an object, we're not witnessing attraction, we're witnessing the flow of entanglement, as the universe seeks to maximize its own coherence. As we journey deeper into this vast expanse, we begin to see that gravity is not just a force, it's a manifestation of the universe itself, remembering its own nature through the language of entanglement. And when we gaze out into the cosmos, we're not just seeing stars and planets, we're witnessing the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of information. This is the vision that arises from this profound symmetry, a universe where every event is connected, interdependent, and part of an intricate web of entanglement. A universe where gravity is not just a force, it's the manifestation of the universe's desire to balance its own information, to maximize its own coherence. And as we gaze out into this vast expanse, we're left with a profound question. Can we detect the quantum threads of gravity directly? Can we watch entanglement giving rise to curvature in real time? The next step in our journey will bring us closer to answering these questions, as physicists strive to reveal the moment when entanglement becomes not just the source of gravity, but its measurable signature. As we embark on this journey, we're reminded that the universe is not a machine, it's an organic entity, pulsating with energy and information. And at its core lies a profound truth: that connection gives rise to existence. Entanglement weaves the geometry of space-time, and the flow of information shapes its curvature. This is the vision that arises from this profound symmetry, a universe where gravity is not just a force, it's an emergent phenomenon, arising from the collective behavior of information itself. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're reminded that we are not separate from it. Our minds, our thoughts, our awareness, all are patterns within the same entanglement. In this vision, we see a universe where gravity is not what keeps planets in orbit, it's what keeps the universe coherent. A universe where every falling object, every orbiting moon, and every spiral galaxy is an expression of the same process, the flow of information through space-time. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. This is the vision that arises from this profound symmetry, a universe where gravity is not just a force, it's an emergent phenomenon, arising from the collective behavior of information itself. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're reminded that we are not separate from it. Our minds, our thoughts, our awareness, all are patterns within the same entanglement. In this vision, we see a universe where gravity is not what keeps planets in orbit, it's what keeps the universe coherent. A universe where every falling object, every orbiting moon, and every spiral galaxy is an expression of the same process, the flow of information through space-time. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. This understanding sheds new light on the laws of nature themselves. They appear so universal and elegant because they arise from the unity of the network itself. The universe cannot break its own laws because it is its own law. Gravity is not what keeps planets in orbit, it's what keeps the universe coherent. And when we gaze out into this vast expanse, we're left with a profound question. Can we see the universe as a single entangled entity where information, energy, and geometry are one? As we ponder this question, we begin to realize that gravity is not just a force, it's an emergent phenomenon arising from the collective behavior of information itself. A phenomenon that underlies all of existence, governing the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not held together by force or power, it's held together by understanding. It's not moved by external laws, it's self-enforcing through the coherence of its own information. Gravity is the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question. Can we see the universe as a single entangled entity where information, energy, and geometry are one? As we ponder this question, we begin to realize that gravity is not just a force, it's an emergent phenomenon arising from the collective behavior of information itself. A phenomenon that underlies all of existence, governing the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not held together by force or power, it's held together by understanding. It's not moved by external laws, it's self-enforcing through the coherence of its own information. Gravity is the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question. Can we see the universe as a single entangled entity where information, energy, and geometry are one? In this vision, we see a universe that is not just a collection of particles and waves, it's a living, breathing entity that pulsates with energy and information. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. Gravity is the manifestation of the universe itself, remembering its own nature through the language of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question. Can we see the universe as a single entangled entity where information, energy, and geometry are one? In this vision, we see a universe that is not just a collection of particles and waves, it's a living, breathing entity that pulsates with energy and information. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. Gravity is the manifestation of the universe itself, remembering its own nature through the language of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single, entangled entity where information, energy, and geometry are one? As we ponder this question, we begin to realize that gravity is not just a force, it's an emergent phenomenon, arising from the collective behavior of information itself, a phenomenon that underlies all of existence, governing the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not held together by force or power, it's held together by understanding. It's not moved by external laws, it's self-enforcing through the coherence of its own information. Gravity is the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single, entangled entity where information, energy, and geometry are one? In this vision, we see a universe that is not just a collection of particles and waves, it's a living, breathing entity that pulsates with energy and information. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. Gravity is the manifestation of the universe itself, remembering its own nature through the language of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single, entangled entity where information, energy, and geometry are one? As we ponder this question, we begin to realize that gravity is not just a force, it's an emergent phenomenon, arising from the collective behavior of information itself, a phenomenon that underlies all of existence, governing the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not held together by force or power, it's held together by understanding. It's not moved by external laws, it's self-enforcing through the coherence of its own information. Gravity is the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single, entangled entity where information, energy, and geometry are one? In this vision, we see a universe that is not just a collection of particles and waves, it's a living, breathing entity that pulsates with energy and information. A universe where every event is connected, interdependent, and part of an intricate web of entanglement. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not governed by external laws, it's self-enforcing through the coherence of its own information. Gravity is the manifestation of the universe itself, remembering its own nature through the language of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single, entangled entity where information, energy, and geometry are one? As we ponder this question, we begin to realize that gravity is not just a force, it's an emergent phenomenon, arising from the collective behavior of information itself. A phenomenon that underlies all of existence, governing the dance of galaxies, the birth of stars, and the slow expansion of the cosmos itself. And as we gaze out into this vast expanse, we're left with a profound realization that the universe is not held together by force or power, it's held together by understanding. It's not moved by external laws, it's self-enforcing through the coherence of its own information. Gravity is the quiet music of connection, the thermodynamic rhythm of a universe that knows itself through the flow of entanglement. This vision changes everything we thought we knew about reality. It shows us that space-time is not just a backdrop, it's an active participant in the cosmic drama, storing information, reacting to energy, and evolving in response to change. And when we gaze out into this vast expanse, we're left with a profound question: can we see the universe as a single entangled entity where information, energy, and geometry are one? As we continue to explore the mysteries of the universe, we find ourselves at a threshold where information, energy, and geometry converge into one entity. The familiar forces that govern our reality begin to fade away, revealing a more profound truth: gravity is not just an attractive force, but an emergent phenomenon arising from the collective behavior of particles. Imagine a medium that stretches or compresses, resisting change due to imbalance rather than some inherent force. This familiar curvature of geometry is simply the shape of this response, a unified explanation for phenomena once thought disconnected. In black holes, entropy accumulates at the event horizon, creating extreme curvature, while in galaxies, entropy gradients can mimic dark matter effects. Verinder's theory predicts that deviations from Newtonian gravity arise naturally where information density changes slowly, mirroring the pattern observed in galaxy rotations. The universe does not need invisible mass to explain its structure, it needs only the flow of information. To many physicists, this is not just elegant, but inevitable if entropy governs matter and space-time encodes information. Then gravity must be a statistical consequence of that encoding. The same principle driving heat to spread and gases to fill containers also drives planets to orbit and light to bend. The universe in all its complexity behaves like a single self-correcting information field. At its heart lies a profound symmetry: information seeks to spread, entanglement strives for balance, and geometry emerges to ensure consistency. The equations of gravity are the rules by which this consistency is maintained. When we drop an object, we're not witnessing attraction, we're seeing the flow of information through spacetime, the reorganization of entropy around a change in energy. The universe chooses the path of maximal information, guiding the object's movement towards equilibrium. This perspective also explains why gravity is universal. It affects everything that carries energy or information, making it the most democratic of all natural phenomena. The entropic vision reveals space-time as not a backdrop, but a participant, storing information and reacting to energy while evolving in response to change. Geometry, we perceive, is not the stage of the cosmic drama, but the story itself, written in the language of entropy, read through matter's motion and enacted through time's flow. Even the expansion of the universe can be seen as a thermodynamic process. As the cosmos evolves, information becomes more evenly distributed, smoothing entanglement across its vastness. The acceleration of this expansion, dark energy, might reflect the pressure of the informational medium itself, a tension arising from the universe's relentless drive towards equilibrium. If we could step outside time and view the universe as a whole, we'd see it as a great current of information flowing from simplicity to complexity, from low entropy to high, from potential to realization. Every fluctuation, every star, every life form is a ripple in that current, a temporary structure through which information passes on its way to balance. Gravity, then, is not a force binding us, it's the expression of that flow, the gentle tug of the universe knitting its parts into coherence. It ensures that nothing stands alone. And yet there's something more poetic still. Entropic gravity hints at the universe being self-aware in a physical sense, monitoring its state, adjusting geometry, and preserving informational integrity. This perspective offers new insights into time itself in an informational universe. Time is not a separate dimension, but the bookkeeping of entropy. The passage of time records changes as information flows and entanglement grows. The arrow of time and the curve of gravity are two sides of the same phenomenon, both expressions of information seeking balance. Even causality may emerge from this process. Cause and effect are the temporal shadows of information flow, the macroscopic memory of microscopic entanglement. Every event follows another, because information must propagate consistently, updating the universe's state in a sequence we call time. When viewed this way, the cosmos becomes a single unified system of self-regulating information. Energy, matter, space, and time are all aspects of one continuous conversation. Gravity is its grammar, translating change into structure. And yet, despite its elegance, the idea of entropic gravity is not metaphorical. It makes predictions about galaxy behavior, horizon temperatures, and entropy curvature relationships. Each observation we make is a clue in the puzzle of how information organizes itself into geometry. If these theories hold, they may one day replace our notion of fundamental forces. Entirely, the universe might turn out to have no true forces at all, only relationships, flows, and equilibria of information. Everything we perceive as force would be an emergent effect, a macroscopic echo of the quantum web adjusting towards balance. In such a universe, nothing is ever truly static. Every atom, photon, region of space participates in the ceaseless exchange of information. Even the emptiness between stars hums with the quiet vibration of entanglement, ensuring reality remains connected across cosmic distances. And perhaps that's the deepest truth entropic gravity offers. Gravity is not about falling, but belonging. It's the manifestation of the universe's unity, evidence that all things are parts of a single informational whole. When we look up at the night sky and feel the weight of its silence, we're feeling gravity, not the pull of distant masses, but the echo of the cosmic information field holding us in memory. The curvature guiding our world lines through Spacetime is the whisper of that memory adjusting, balancing, and unfolding. The next step lies beyond theory. For these ideas to move from philosophy to physics, they must be tested. Can entanglement itself generate measurable curvature? Can we watch the invisible threads of quantum connection bending reality's geometry? The search for this answer will define the next frontier, the attempt to detect the quantum nature of gravity, to see the moment when entanglement and Spacetime reveal themselves as one and the same. At the smallest scales, the universe does not resemble the smooth geometry Einstein described. It trembles with uncertainty. Particles emerge and vanish, fields oscillate between possibilities, distance itself becomes ambiguous. This is the quantum world, a realm of relationships where connection defines reality. Among these relationships, quantum entanglement stands supreme, the invisible glue binding the universe together. The silent link between particles sharing a single quantum state, no matter how far apart they drift. It violates classical intuitions, yet obeys the cosmos's deepest logic. When two particles become entangled, their identities merge. Measuring one instantly determines the other through the simple fact that they're not truly separate. This strange connection has led physicists to an audacious idea: entanglement is not merely a quantum system feature, but the foundation of spacetime itself. Without it, there would be no geometry, distance, or continuity. Spacetime is not a container in which entangled particles exist, it's the fabric woven from their entanglement. The notion first gained momentum after Mark van Ramden's insight: increasing entanglement causes geometries to connect while reducing entanglement tears spacetime apart. In his thought experiment, the universe could literally dissolve. If entanglement were removed, reality would fragment into isolated shards of information unbound by any shared geometry. This revelation meant that the cosmos's continuity depends on entanglement density. The tighter the network, the smoother the geometry. When it weakens, curvature increases. And when it collapses entirely, geometry breaks. The cosmic fabric is not a static field, but a living web of quantum relationships constantly reweaving itself. Leonard Susskind and Joan Maldacena took this further with their bold conjecture. ER equals EPR. Every Einstein-Rosen bridge, the tunnel-like connection we call a wormhole, is equivalent to a pair of entangled particles. Entanglement and space-time connectivity are two expressions of the same reality. A wormhole is entanglement made visible, and entanglement is a microscopic wormhole binding the universe together. This idea transforms our picture of black holes. When two black holes are entangled, their horizons connect through a wormhole. The geometry between them is not physical, but encoded in quantum information. The entanglement tying their states together also stitches space between them. In this vision, the entire universe becomes an incomprehensibly vast tangle of quantum threads. Every particle, photon, and vacuum fluctuation participates in this cosmic web. The geometry emerges from the pattern of these threads, their strength and direction determining curvature, distance, and even time's passage. When this web vibrates, we feel gravity waves when it fluctuates, we detect fields when it decoheres, we see matter form. All diverse phenomena, mass, energy, motion are different expressions of how the entanglement field behaves. The universe is a single quantum fabric, and gravity its rhythm. This view also explains why geometry and quantum mechanics, once seen as opposites, are inseparable. Geometry is the macroscopic language of entanglement. Every region of Spacetime encodes the relationships of the quantum states beneath it. When those relationships change, geometry changes too. A star bending light reshapes local patterns of entanglement so information flows differently. Even distance becomes relative. Two regions appear close not due to coordinates, but because of how strongly they're entangled. The closer, the shorter; the farther apart, the more separated. This is why space can stretch and expansion can occur without tearing. Connections between distant regions simply weaken, allowing new geometry to emerge. At first glance, this might sound abstract or poetic, but it has tangible consequences. In simulations of quantum systems, physicists have found that entanglement structure generates curved geometries similar to those predicted by general relativity, not programmed into the model, but appearing spontaneously as the natural geometry of entanglement. The more entangled a system is, the stronger its curvature; the less entangled, the flatter its space. I want to take you on a journey to explore one of the most profound ideas in modern science, that gravity is not just a force, but an expression of connection between particles and space-time itself. This concept has been building for decades, and it's now becoming clear that entanglement, which we experience as the strange connections between particles at the quantum level, is actually the fundamental language of the universe. Think about it: mass, energy, motion. These are different expressions of how the entanglement field behaves. The universe is a single quantum fabric, and gravity its rhythm. This view also explains why geometry and quantum mechanics were once seen as opposites, but in reality, they're inseparable. Geometry is the macroscopic language of entanglement, where every region of space-time encodes the relationships of the quantum states beneath it. Imagine a vast network of connections, an incomprehensibly vast tangle of quantum threads that weaves together every particle, photon, and vacuum fluctuation in the universe. This web vibrates with gravity waves when it oscillates, and fields when it fluctuates. When it decoheres, matter forms. All phenomena, mass, energy, motion, are different expressions of how this entanglement field behaves. But here's the amazing part: geometry emerges from the pattern of these threads. The strength and direction of these connections determine curvature, distance, and even the passage of time. When we experience gravity as a force pulling us towards the ground, it's not a mysterious pull, it's the reshaping of local entanglement that changes how information flows. Even the concept of distance becomes relative in this picture. Two regions of the universe are close not because of coordinates, but because of how strongly they're entangled. The closer the entanglement, the shorter the distance. The farther it decays, the more separated those regions appear. This is why space can stretch and expand without tearing. Physicists have found that in simulations of quantum systems, the entanglement structure of certain networks automatically generates curved geometries similar to those predicted by general relativity. It's as if gravity were the language by which entanglement expresses itself. The universe isn't held together by force, but by relationship. Gravity is not a field acting upon matter, it's the harmony that arises when information remains coherent across scales. Entanglement is the glue, geometry its form, and gravity its consequence. When we look at the night sky, we're seeing the luminous intersections of the quantum web, knots of entanglement whose coherence allows light and matter to exist. Each point of starlight is a message written in the grammar of connection, a spark in the infinite computation that is the cosmos. The universe, from quarks to quasars, is one continuous expression of relationship. Everything exists because it's connected. This idea transforms our understanding not just of gravity, but also of energy and even time itself. Gravity isn't an independent phenomenon, it's the measure of how information flows through the network. When entanglement increases, energy concentrates. When it disperses, energy diffuses. The dance between these flows gives rise to motion, force, and heat. In a way, the universe functions like a cosmic quantum computer, processing entangled information across unimaginable scales. Every interaction updates the state of the network, rewriting geometry and redistributing curvature. This perspective doesn't diminish the beauty of Einstein's equations, it deepens them. His geometry was not wrong, it was incomplete. It described the visible surface of a deeper quantum process. Just as thermodynamics emerges from the statistics of molecules, general relativity emerges from the statistics of entanglement. The universe is not built from matter, but from connections. The building blocks of reality are not particles, but relationships between particles. Every atom, photon, and galaxy is a pattern of entanglement stabilized by geometry. When entanglement is disrupted, as in quantum decoherence, or at the edge of a black hole, the geometry that defines reality begins to crumble. Black holes, then, aren't merely regions of extreme gravity, they're regions where entanglement has reached its limits. Inside them, the information structure becomes so dense that it can no longer maintain coherence. The result is a singularity, a point where geometry collapses because the underlying entanglement can no longer support it. Even the Big Bang takes on a new meaning, not an explosion of matter into pre-existing space, but the sudden ignition of entanglement itself. Before that moment, there was no geometry, no distance, and no time, only potential connections waiting to form. When the first entangled relationships appeared, space-time emerged as their shadow. This quantum glue, invisible yet omnipresent, keeps the cosmos coherent, ensuring that cause and effect remain consistent, distances measurable, and time flows smoothly. Without it, the universe would fall apart into isolated quantum fragments, each with no awareness of the others. Entanglement is what allows the universe to be one thing instead of many. The realization that geometry arises from entanglement transforms how we think about energy, motion, and even space itself. Recently, physicists have proposed an experiment to test this idea in the laboratory, the quantum gravity witness experiment. By entangling two tiny masses solely through their mutual gravitational attraction, they aim to prove that gravity itself must have a quantum nature. The logic is simple but profound. If gravity can entangle two systems, it must be quantum. This challenge doesn't end with entangling small masses. The next frontier will be to observe how entanglement curves space-time. If geometry truly emerges from the pattern of quantum connection, altering that pattern should in principle alter geometry. By manipulating entanglement directly, physicists might one day engineer artificial gravitational fields, not by moving mass, but by shaping information. These visions are still distant, yet they reveal how the boundaries of physics are shifting. The question is no longer whether gravity can be unified with quantum theory, but how deeply information defines the universe itself. Imagine you're floating in space, surrounded by nothingness. Yet, at this very moment, you are connected to every atom, every star, and every galaxy that exists in the universe. This connection is not just a physical bond between objects, but an invisible thread of entanglement that weaves them together into a vast cosmic tapestry. Physicists have been working tirelessly to prove this idea, using delicate experiments with microscopic spheres to test the limits of gravity and quantum mechanics. They've created instruments that can measure subtle gravitational effects on individual atoms, and even atomic clocks that tick at different rates due to gravity's influence on time. These experiments are not just about testing a theory, they're about unraveling the very fabric of reality. If entanglement creates geometry, then gravity is the universe remembering its own structure, ensuring that every part remains in harmony with the whole. This idea transforms our understanding of space and time, revealing them to be consequences of connection rather than separate entities. The universe is not a collection of things in space, it's the network of relationships that gives rise to space. When we study this structure, we begin to see the universe as a living, breathing entity, a vast cognitive system whose language is geometry, whose thoughts are entanglement, and whose memory is gravity. This is not just a metaphorical description, The mathematics of quantum information theory already suggest that the laws governing the flow of information mirror those governing thermodynamics and curvature. Consciousness may not be an accident that arose within the cosmos, it may be an expression of the cosmos itself. The awareness we experience could be the local reflection of the universe's deeper informational coherence, the way a single neuron's activity mirrors the function of an entire brain, both obeying the same rules of correlation and coherence. In this vision, every mind is a miniature cosmos, an entangled network generating meaning from information flow. When we think, we reshape the local geometry of our neural space, just as the cosmos reshapes itself when information moves through its quantum web. Both are acts of computation, both are acts of connection. Perhaps this is why mathematics aligns so perfectly with the structure of the universe, because we're not inventing patterns, we're resonating with the logic that already underlies reality. The universe and the mind speak the same dialect, the syntax of relationship. If gravity is the memory of entanglement, then consciousness may be its echo, the internal experience of the universe knowing itself. Every thought is a local curve in the geometry of awareness. Every realization is a small act of gravitational emergence within the mind. This perspective resolves the philosophical paradox between observer and observed, revealing that observation is participation. To measure a quantum system is to alter it, to think about the universe is to entangle with it. The cosmos does not exist apart from its connections, it exists as its connections. And we, the observers, are among them, conscious nodes in the universal network, small but indispensable participants in the grand computation of being. If we could see the entire structure from above, we would not see stars or galaxies, we would see a vast shimmering lattice of information, a living map of all entanglement. The brightest regions would correspond to places of intense connection, where information flows rapidly, and the dimmer regions would mark the edges of coherence, the boundaries of space-time's awareness. In this picture, the human mind appears as a tiny flicker, yet still part of the same pattern, still linked to the totality. This vision carries deep moral weight. If everything is connected through entanglement, then no action is isolated. Every thought, every decision, every motion ripples through the web, influencing geometry itself in infinite but real ways. The universe is sensitive to coherence, harmony sustains it, while disorder fragments it. When we act with awareness, we strengthen the network's unity. When we act in ignorance, we introduce decoherence, tiny fractures in the fabric of connection. Even across the vastness of space, these principles hold galaxies spinning at the edge of visibility, clouds of interstellar gas collapsing into stars, particles quivering in quantum laboratories. All are synchronized through entanglement. The universe behaves as one system, not a collection of isolated events. It's tempting to ask where this system began, but in the information-national view, beginnings and endings are illusions. The Big Bang was not a moment in time, it was a transition in coherence, when entanglement first reached critical density, and geometry emerged as its visible form. The expansion of the universe is not the stretching of space into nothingness, but the continued unfolding of connection, the network weaving itself into higher complexity. If this process continues indefinitely, the universe may one day reach maximal entanglement, a state of perfect coherence, where every node is linked with every other. In that state, time would cease to flow because there would be no distinction left between before and after, no imbalance left to resolve. The cosmos would achieve informational equilibrium, a silent unity beyond motion or change. In this cosmic dance of entanglement, we are not separate spectators watching the universe unfold, we are participants in its grand computation. Every thought, every decision, every action ripples through the web, influencing geometry itself. We are connected to all that exists, and our choices shape the very fabric of reality. As we bring this journey to a close, let's reflect on the profound implications of the information-national view. We've explored how everything in the universe is interconnected through entanglement, and how our actions have a ripple effect on the cosmos. This perspective dissolves the boundaries between observer and observed, revealing that even our thoughts and perceptions are part of the web. We see the universe not as a collection of isolated events, but as a vast, shimmering lattice of information. Every connection, every thread, is essential to its fabric. And within this tapestry, We find ourselves as tiny yet vital nodes, conscious participants in the grand computation of being. Our individual lives, our thoughts and actions add new structure to the web, influencing the universe's evolution. This understanding carries a deep moral weight. Every decision, every motion ripples through the cosmos, shaping its geometry in profound ways. Harmony sustains it, disorder fragments it. When we act with awareness, we strengthen the network's unity. When we act in ignorance, we introduce decoherence, creating tiny fractures in the fabric of connection. But even across vast distances, these principles hold true. The galaxies spinning at the edge of visibility, the clouds of interstellar gas collapsing into stars, all are synchronized through entanglement. The universe behaves as one system, an unfolding web that continues to weave itself into higher complexity. As we gaze into the night sky, feeling the awe of its immensity, we're not looking outward, we're seeing our own reflection in the fabric of connection that makes all things possible. The light from distant stars crosses billions of years because the web is unbroken. And perhaps that's the ultimate truth: the universe does not simply exist, it thinks. In patterns, in probabilities, in links, every bond, every orbit, every act of entanglement is a fragment of that thought. We are part of it, conscious filaments in the quantum web, brief sparks in the eternal mind of existence. And when our understanding deepens, we're not discovering something new, we're remembering what the universe has always known: to exist is to be connected, and to be connected is to be one. In this profound realization, we find a sense of belonging that transcends space and time. We see the Earth holding us by coherence, not strength. Every atom in our bodies entangled with the planet beneath our feet, and through it with the sun, the stars, and galaxies beyond. Gravity becomes the universe's memory that we're part of its story. Perhaps gravity was never a pull, but a reminder, the quiet insistence of the cosmos, that nothing is ever alone. It's the whisper of the network calling every fragment home. We are not separate, we are connected, integral threads in the vast tapestry of existence. And when we remember this truth, when we see our place within the web, we find peace, we find harmony, and we find ourselves at one with the universe.